So we are going to start today with Unit 3, the chapter named Remote Sensing. This appears in Surveying 2, Unit 3 as per Goa University's curriculum. Okay, and the books that I have preferred for this particular chapter is Remote Sensing for Beginners by Pradeep Kumar Guha and Basics of Remote Sensing in GIS by Dr. S. Kumar. You could also refer your usual textbooks, that is B.C. Punya, if I'm not mistaken, Volume 2. Alright, so what is remote sensing? As the word says, remote sensing means sensing from distance. That's why we call it remote, remotely sensed data. So what we're doing in case of remote sensing is we are trying to gather information about various objects. We may be trying to find out their area, we may be trying to find out distances. But while doing so, we are not actually coming in contact with these objects. So when we started studying Surveying 1, we had studied two methods of carrying out survey. One was called direct, second was called indirect. In direct, what we studied certain objects like tape, chain, wherein if I have to find, let's say, distance between the 2 points, I had to actually take a tape and stretch it, connecting the 2 points to get the distance. So after doing this direct surveying, we studied something called indirect surveying, wherein we are not actually going and measuring the distance between the 2 points using a tape, but instead we are just taking few observations on those objects, and then we had equations which were relating these objects, which would give me the information that I required, in this case the distance. Like for example, we studied tachyometry. In tachyometry, what we did, we just held the staff between the 2 points whose distance was required. We took the staff intercept, and based on the staff intercept and the angles that we measured on the tachyometer, we got the distance between the two objects. Now, can we consider this indirect surveying? In our case, like surveying using tachyometer or total station, can it be called remote sensing? No, it cannot be. The reason being, for any method of surveying to be called as remote sensing, you should be first gathering information from distance without placing anything, any part of the instrument or any gadget on the object. So what is important is this: you have to, without placing any sensor or instrument in contact with them. Now when we are doing tachyometry, what we do, we keep a staff on the object, right? Without the staff we can't do. Let's say now when we are doing total station, when we are taking readings on total station also, we need to keep our prism. Now some places prism may not be required. Okay, you are only focusing at a particular point, and then you are finding out the distance of that point from the instrument, or distance of 2 points. But in any case, you have to at least mark something. Let's say you are on the total station and there is no need, let's say you have not approached the object at all. Say you are at a point and you are trying to find out the deformation of a bridge deck. You just want to sense what is the level of the bridge deck when there is no loading and when you load a truck. This is how I have seen, you all must be also convergent. How do we determine whether the deformation of the bridge deck is within permissible limits? So what they do is they take the readings on a point on the bridge deck without any kind of traffic on it, and then they subject it to maximum possible traffic, see the amount of deformation of the deck, and note down the reading again. That's how you come to know how much is the deformation happening. Now in such case, wherein there is nothing, there is no prism, there is no instrument, in that case it is actually complying with your definition. But as long as you are making any kind of markings, you are actually approaching the object. In that case, you don't consider that method of surveying as remote sensing. So, to give you an example of remote sensing, the experiment that you all conducted, the 7th experiment that you all conducted on interpretation of satellite images. So what actually is happening is you have sensors which are placed on the spacecrafts or on satellites or aircrafts, and they are taking images. They are taking images in different bands of electromagnetic spectrum. Okay, so what is the electromagnetic spectrum? We have studied this in physics, but let's revise. So you must have seen this. This is the electromagnetic spectrum. Okay, so when we take a mobile and click a photograph, we are clicking photographs in this range, 7 into 10 raised to 14 hertz to 4 into 10 raised to 14 hertz. This small part of the electromagnetic spectrum is what is visible to human eyes. Okay, so that 7 into 10 raised to 14, 4 into 10 raised to 14, this, if you break it down, you will get these different colors. Okay, so when we, as a kid, when we used to mix these colors, what used to happen if I had to mix all these colors, we used to get black color. But exactly opposite of it happens when you are dealing with radiations. So when you mix all these colors, the light of all these colors, rather, if I say, okay, you will get white color. That's why we see in the daylight everywhere it is white. You don't see colored things. You see a white, bright light outside because it's a mixture of all these wavelengths. Now, if you look at this electromagnetic spectrum, look at the frequencies. It's 10 raised to 24 to 10 raised to 2 hertz. Okay. Anything less than 7 into 10 raised to 14, anything next to this blue line is ultraviolet light. Anything above the red line is infrared. Now, when we are taking observations, we make use of this band, the visible light, and then beyond it. Now, as we go further, we will understand what is the significance of each of these bands. Okay. Our satellite records the images in different bands. If you have done the 7th experiment, which I had told you to download the image from LIS3, from the Bhuvan portal, okay, you will realize that the satellite has recorded readings in various bands. What we are doing is we are overlapping these images which are collected in different bands to get a color composite image. Okay, so each of these bands, so why are we actually taking the readings in different bands? Because each band has its speciality. Okay, there are certain features of an image. Now, image will have texture, image will be exhibiting the temperature, image will be exhibiting the moisture content. All these things are enhanced in various bands. Microwave band has properties to capture certain properties of an image very clearly. Similarly, infrared has a different advantages and limitations. So we will study that in depth. What is the peculiarity of each of these windows, each of these wavelengths when we are doing the applications of electromagnetic spectrum. Okay. So now let's go back to the slide that we were discussing. So in remote sensing, what is done is we make use of these various parts of electromagnetic spectrum, the visible, infrared and microwave regions, and we collect information in each of these parts. Understood? And then, based on the color composite image developed, we try to interpret the image, give some legible information, understandable information, okay, easy to understand information. So all these bands are used. You collect the data in different bands, okay, and then convert it to a more readable format. Okay, so now let's come to the components of remote sensing. There are two components of remote sensing. One is data acquisition and second is data analysis. Now these are the steps involved in data acquisition. First you have energy source, then you have electromagnetic radiations, then you have propagation of radiation. Okay, the next thing is interaction of radiation with matter. Then you have sensors. You have active and passive sensors based on the source, if it's an artificial one or is it a natural source. Based on that, we divide the sensors into active and passive. Then you have platforms on which these sensors are mounted. So they may be ground-borne platform. You may have airborne. Airborne are in as in aircrafts or spacecrafts, or spaceborne, which are satellite. Then you have the next component is recording of signals, then transmission to the data to the ground, then conversion of electronic data into CCT. CCT is color composite transforms. Then acquisition of ground data, then interpretation of this ground data, ground checking, evaluation, and generation of information for users. In brief, if you are finding it difficult to memorize, all you need to understand is this. So what is happening over here? You have the source. What does the source do? The source sends the electromagnetic radiations downwards. Okay, these electromagnetic radiations will interfere with all the features on Earth. Now it may be ground, it may be water, it may be snow, and when it interacts with the images, okay, that interaction will be caught by the sensors, which will be mounted either on aircrafts or mostly on satellites. So to give you an example, if you try to take the image that we studied in our experiment. So this was what we did in the experiment. Okay, you all downloaded these images. If you can see, all these images have different things. They don't look similar. Okay, the first image is captured in green band. Second is captured in red band. Third one is captured in infrared band. Fourth one is after you overlap all this, if I'm not mistaken, this is a false color composite. Okay, now similar thing we did for Greater Mumbai, and we had downloaded an image from list 3, which was, if I'm not mistaken, in 4 bands. Here in the example in your lab manual, there are 3, and this is the composite image which is found by overlapping all 3. We had 4, we overlapped 4, and we got an image like this. We got an image like this. Now, when we take images in particular bands, why do we take it in different bands? Like, for example, when we take with a camera, we take everything in one band, that is visible spectrum, right? And instead of that, when you take images from satellite, we take it in different bands. We take one in infrared band, we take something in blue band, we take something in gray band. Why do we do that? Why we do that is because each of these bands have certain advantages. I will only discuss a few. I will discuss all when we are talking about application. Okay, so here I am referring to your lab manual, a part of your lab manual which is giving you details of the image that you all downloaded from Bhuvan portal. Now that image was recorded in 4 bands. It was recorded using from the satellite. List 3 had captured it. I'm not sure. Just find out if it is active. It is still active or not. Don't think it is still active. Okay, so now list 3 recorded in 4 bands. Okay, out of these 4 bands, B2, B3 were from visual part of the EMS, B4 recorded in near infrared, and B5 recorded in shortwave infrared. I'm not going to repeat what we did already in the practicals, but I'm just trying to give you all an example. So if you look at this, B2 is in the visible region, B3 is in visible region. Then what we did while creating the color composite image, what we did, we assigned these bands a certain color. So try to memorize this. So what we did is we assigned colors to these bands. Band 2 and 3, which was picked up in visible part of the spectrum, was given blue and green color. Okay, band 4, which was infrared, was given red color. And band 5, which was shortwave infrared, was given gray color. Now, I don't want to go one by one. I will just try to explain you. What I was actually trying to tell you all is the importance of all the parts of the spectrum. Why we collect images in all these infrared and microwave band. Now, if you look at this, just concentrate on this. Infrared, whatever is picked up by infrared color will be looking red. Now, what is the significance of this infrared part of the spectrum? Now this is a typical usage of the bands. Okay, this is also from your lab manual. Now let's concentrate on this. Near infrared. Near infrared will be used basically to depict vegetal cover. Okay, this particular band, near infrared, mid infrared band, okay, this is very much used in order to pick up images of vegetation, soil moisture content. These particular attributes get very well highlighted in the image. So when you take photograph of vegetal cover, or let's say soil, slight variation in the moisture content, it will be very well noticed if it is picked up in infrared region. So now let's go back to our image. Purposely not taken a complete image. I want this as well as this part of image on the screen. So now you look at this. Band 4 which is picked up in infrared will be looking red. Again I told you infrared is very good at highlighting the difference in the moisture content, water content of soil as well as the vegetal cover. So if you can see here, whatever is red in color, okay, this is basically your vegetal cover. Now if you look at this, something which is near the water body is looking deep red in color, which means the moisture content in these areas is huge. Now you will say, why don't we directly take images in visible band like how we get on Google Earth or Wikimedia. There also it shows us which are the mangroves and which is the pasture land and which is a forest cover. Yes, it does. But here we are only talking about an image which is in 4 band. Because you all are studying at beginner's level, I have told you all to download this particular Greater Mumbai image because it was only taken in 4 bands. If you go to any other place, okay, on the same software, you will realize that for one particular place, the images are taken in many bands. They are called multispectral images. There will be somewhere around 9, 12, many bands. So when you take so many bands, okay, here it is just 4 bands. When you take so many bands, the information collected will be much more. In microwave, here in this, there is no band which is collected by microwave region. If you collect information in microwave region, you will be able to understand even the texture of the object. Okay, so let's go back to our PowerPoint. Back to the parts of remote sensing, and we were at the first part, that is data acquisition, and we were here. After the energy resource, what we were discussing is interactions with surfaces. So every part of this electromagnetic spectrum, every band has certain way to interact with the surface, and that is picked up by the sensors which are either airborne, or ground-borne or space-borne, and then they send all that onto the ground station. At the ground station, what you do? You start processing and analyzing. So what you all did in your experiment is you did this, data processing and analyzing. So as it is, whatever data was collected, would you be able to comment on that? The black and white or the black and gray images that you all got, would you be able to speak anything about it? Would you be able to offer comments on it? No. So what we did, we processed that data and then we try to analyze it. So a lot of time, if you all are well versed with this image interpretation or image processing, you could do a lot of work. You could take an image. Now on Bhuvan already I told you there are free images. So you could take image of one particular place, let's say Goa. The image is captured from satellite in different time range. Like you could collect something which was in 2016, you could collect something of 2015. You can find out how much is the depletion of the vegetal cover. You could find out how now, even in that Greater Mumbai image, if you go back to your lab manual, you will understand that even water is can be seen in different colors. You see, the dark blue color represents fresh water. You can see here, not here, sorry, here. The in between water land that is trapped, this is fresh water. okay, because this is in dark blue. Okay, anything lighter will represent salt water. How can you make use of this particular knowledge? You could check for our freshwater resources near the coastal area. Okay, at different time periods, you could find out how was our freshwater resource in 2016 and how it changes in 2020. If you can see the change in color, you could estimate the amount of pollution that has happened or the amount of intrusion, mixing of the salt water and fresh water. So there are multiple ways you could interpret these satellite images. Now in this particular image, you can see somewhere there is dark red, somewhere there is brighter red, somewhere there is deeper red. Here it is still more deeper red. Now over the time, if I tell you, if this deeper red starts becoming lighter red, then what do you understand? What do you interpret from it? Our first interpretation will be there is depletion of the soil moisture content. So that can be analyzed. Again, I told you, if you have a better command on image processing or interpretation of satellite images, you could use this entire thing to even find out which part of Goa is under clay or which part is under sand, and you can have a map of Goa for various types of soils. So there are ample of information which you can collect using satellite images, which is not possible when you take all the images in visible bands. Alright, so going back, next component of remote sensing is data analysis. So data analysis is basically you start processing the digital images, and once you process them, then you start interpreting them. You start deriving conclusions from them. Alright, the next subtopic is platforms. Remote sensing platforms. Now what do you mean by platforms? I just told you, you have sensors which are mounted on ground-borne, airborne and space-borne platforms. If the area that you are trying to study is very small, let's say you want to analyze a field, a small patch of green land, okay, or a river, a local part of a river, then you may use some ground-borne platforms. These will be instruments which will be mounted on tripods or handheld instruments. Okay, if you want to cover a little bigger area, then you will go for airborne platforms. Now, airborne platforms will be basically airborne sensors will be the ones which will be mounted on aircraft. Okay. Now, if you want to go for still larger area, you will go for spaceborne platform. That is your satellite images. Here, the scale will be way much larger, right? Then the next thing is remote sensing systems. Okay, now remote sensing systems primarily of two types. One is active and one is passive. Now active system is the one that makes use of man-made source of energy, and passive is the one which utilizes naturally occurring source of energy. Which is a naturally occurring source of energy? Obviously sun. Okay. Now if you have a camera which is taking photographs, a photography camera or television camera, okay, and it's picking up the images in normal daylight, it becomes a passive system of remote sensing. However, if it is using a flash bulb, then it is no more passive. It's making use of a man-made source of energy. Then in that case, it doesn't become a passive system. Okay, an active system example will be a radar, okay, or let's say a X-ray machine. Okay, X-ray machine does not take images in natural daylight. Okay, so there is one tabular column I have made as a comparison between active and passive remote sensing. I do not want to read out in this because it's time consuming. You could pause and go through the different points because this is a very important comparison based on the energy resource, based on the regions of EMS, electromagnetic spectrum, in which it operates. Active will operate on microwave and passive will operate in visible and near infrared region. right? Then the wavelengths will be longer than 1 millimeter. Here the wavelengths will be in the range of 0.4 to 10 microns for passive. Similarly, a dependence on solar energy, as the definition itself suggests, in case of active, it will not depend on a natural energy resource. It doesn't depend on solar radiations at all. While passive will be totally dependent on the solar radiation. So we'll stop here. We'll continue in the next class with the remaining part of the portion.